Hi. Now, Chapter 3, Derivatives, which is the major subject of Calculus 1. In this chapter, we'll study derivatives for various functions, including trigonometric functions, exponential functions, inverse functions, and logarithms. And then in Chapter 4, we'll consider applications of derivatives. Okay, let's begin section 3.1, tangent lines and the derivative at a point. Earlier, we defined tangent line roughly as the limit of the secant lines as q approaches p. For given p, the point, and you can here put another point near around P, and you can make a secant line, and as Q approaches P from the right and from the left, if the limit of the secant lines exists, then the limit is called the tangent line. Okay, here we define slope of the curve. That's the number, the limit of the difference quotient. Once this limit exists, then we say that is the slope of the curve. And as you can see from the figure, this average slope and between x0 and x0 plus h, and as h approaches 0, and it will convert to the tangent line, and that is the slope of the tangent line, and also we call it that is the slope of the curve at the point. That is definition. Okay, in this example, let's try to find the slope of the parabola y equal x squared at the point 1, 1, and state an equation of the tangent line to the curve at P. Okay, now we'll follow the definition. Limit h approaches 0 and f of x plus h, okay, x0 plus h minus f x0 divided by h. That is definition of the slope. Okay, that is same as same limit. x0 is now, that is x0, and that is f at x0. Right? Okay, here now f x0, x0 is 1 plus h, f is now here x squared, so that this is 1 plus h squared minus x0 is 1, so that 1 squared divided by h. Okay, that same is now limit, and 1 plus 2h plus h squared minus 1 divided by 2, and this 1 and minus 1 will be cancelled. Oops, at the bottom I write down 2, but that is h. Okay, so that is same as the same limit, and here the first term will become 2, second one will be h. As h approaches 0, it will be 2, so that the slope of the curve is 2. Now, and that is also the slope of the tangent line. So we can make a tangent line. Here we'll try to write down point slope formula. The point is 1 and 1, and slope is 2, so that the tangent line must be here y minus equal, the slope is 2, and x minus x0, which is 1. So that is an equation of the tangent line. You can simplify. Okay, earlier we studied the speed of rock falling freely, and we call it, this one, as the Galileo's free fall formula. And now we try to find here exact speed at t equal 1, which means that the instantaneous speed. So just if we consider this as a curve, then we have to find the slope of the curve. Okay. And now f of t is 16 t squared. So now that is a definition of here the slope of the curve. So that is same as limit and 1 plus h, which is 16 and 1 plus h squared minus 16 and 1 squared divided by h. Okay. If we are focused on this quotient only, then the 16 is common, so that you can put 16 in front of that, and then that is 1 plus h squared minus 1 divided by h. So that is same as 16 times, and oops, that square must be here. So that is now, that is numerator. So it's 1 plus 2h plus h squared minus 1 divided by h. So this 1 and minus 1 can be cancelled, and this division will make here 16 times 2 plus h. Okay, that is the simplified quotient. Now, if you apply this limit as h approaches 0, then the value must be 16 times 2, which is 32. That is the final answer. Of course, the unit is foot per second. Okay. Okay. Now we'll define officially the derivative. The derivative of a function at a point. Now we define the derivative at a point, and we use the here now in notation here now that f prime x0 is this limit. Once the limit exists, then we call it, that is derivative of the function at point x0, and we are using notation f prime x0. So here we used it already, and for given function, once the limit exists, then that is now f prime 1. Okay, that is derivative. So, but this quotient and limit is used earlier as the slope of the tangent line, and also just the slope of the curve. Exactly same number, quantity is used in various the computation and the concepts, and we now call it derivative. Okay. Here, this derivative can be rewritten in this way. Once you write x equal x0 plus h, then x0 plus h can be replaced by x here, and h can be replaced by x minus x0. So we can get that formula. They are the same. Here we have claimed the tangent line to the curve y called fx at the point is the line through the point, and the slope is equal to the derivative of f. Already we know that, right? Okay. if the tangent line to y equal fx at point 43 passes through the point 02, find f prime 4. Okay. Here, this condition is saying that the tangent line to the curve graph at 43 is passing also this point. In this case, it's asking to find the derivative at the point. Pictorially, okay, now xy coordinates, x equal 4, y equal 3. That is a point on curve, and tangent line is passing now here 0 and 2, so that tangent line is given in this way, passing this point. This point is 4 and 3. This point is x equals 0, y equal 2. Okay. So, and we don't know the exact shape of y equal fx. However, that line is the tangent line and passing also that point. Okay, so it is asking f prime at 4, which means that the slope of the tangent line, but this can be easily found here. If this is delta x and delta y, then the slope must be here now. That is change in y divided by change in x. Okay, what is change in y? Which is 1, and change in x is 4. So that is the final answer. Okay? Okay, here we have a summary, and the limit, this number can be interpreted here by this each of this one: slope of the graph, or slope of the tangent line, or rate of the change, or derivative. Either way, you can represent that quantity. So average slope, the difference quotient, and limit, and with that, you can represent each of these things. Okay. Now, before ending the section, we'll do this computation. We have to find and simplify the difference quotient, and then apply limit as h approaches 0. Rather than specific point x0, and earlier we tried to choose x0, for example, in this case is 1, and earlier also 1, and some other points. And in this example, x0 is a specific point. Now, here in this example, rather than specific point, x is a general point, but during this computation is a fixed point, but it's a general x. Okay, let's do this computation. Okay, here for part A, now fx plus h minus f over x divided by h. Okay, that is x squared, so that x plus h squared minus x squared divided by h. This is same as x squared plus 2xh plus h squared minus x squared divided by h. But x squared minus x squared cancelled. And here for remainder parts, divided by h is now 2x plus h. Once you are taking limit of that term, then it'll become 2x. Right? Okay. For general x point, the derivative is 2x. If it is x squared, then that is 2x. Okay. Now, for part B, okay, fx plus h minus f of x divided by h. Okay, that is same as now x plus h cubed minus x cubed divided by h. So it is the same as, okay, numerator x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed and divided by h. So we can cancel these two, and for the remaining parts, and divided by h means that there is a 3x squared, and that is now 3xh and plus h squared. Once you apply limit and h approaches 0, then this will approach 0, so that if you put this whole thing here, then the remaining part will be 3x squared. So that is now derivative of x cubed at general point x. So later on, it'll be used to, it'll be part of formulas for derivative. Okay. Okay. This is the end of section. Okay. Thank you.